Hi, during my previous video we covered the model 1 for a linear regression model. During this short video clip we are going to cover model 2 and model 3. With this we will finish this lecture and we will carry on covering linear regression during week 15, that is after Christmas. So let's go to my full desktop. So this is the model 2, this is the exponential trend model. We already did some exponential forecasting, right? Well, exponential smoothing. The main idea is that we are going to calculate a trend that is in percentage. Yes, so it's growing in a percentage basis. So that means that we are going to have like a some data that is going to look like in the following manner. Yes. Well, so if this is the y-axis and this is the x-axis, yes, you will have something that looks like this. This looks more like an exponential trend, right? So that is why we have here this beta in the exponential. We have here the number e, right? You can please find as a homework what is the number e. Yes. In general, the e is the inverse of the logarithm. So in order to like um, take this guy bt down, yes, here to the numerator we can apply logarithms to both sides of this equation. Yes. So if we apply logarithms to this and logarithms to this, we are going to have that logarithm of yt equal b0, right, plus b1t, yes, plus the error, yes. So that is what we are going to get. So yes, so we are going to fit linear regression with the logarithm of yt. Y, remember, that can be any variable that we are studying, say e.g. GDP, right? And and we are going to use t time as a predictor. Yes, because as we have this trend, we believe that with time, this trend is actually growing exponentially. This is what we have, or what I have after like running the forecast using FDI. But I think here I use outward, yes, FDI, right? So the data is in Blackboard and we calculated this red line here, right? And that red line is this specification. Look how the number E is here. Yes, E number is the inverse of the logarithm, right? So what is the interpretation? With a beta equal to 0.0845. So the logarithm of the forecast in time 148 equal 7.4, yes, plus this coefficient, the time t equal to 148, yes. So as you can see from this equation, right, and we have that then this equal to 7.54, 7.54, right? So if we like use the inverse of logarithm in order to find the expression, we arrive to the e to the this exponential 7.54034, which is equal to 1882.53 thousand riders. Yes, 1882.53 thousand riders, right? And FDI, what is the the expression 0.08, the beta coefficient, FDI increases in average 8.45% per year. So that is what this exponential means. Yes, but is this interpretation valid given the model fit? It looks like it is. Yes, it looks like it is. It's actually fitting very well the data. So we have here the model 3 quadratic trend model. The quadratic trend model, as you remember from my first video, is because we have here a quadratic, yes, component, quadratic component, right? Again, yt can be anything. This is the intercept. This one is the coefficient of time. This is the coefficient. Actually, there is a typo here. This should be beta 2, right? And beta 2 is the coefficient of t to the power of 2, and this is the error. So we are going to fit linear regression with a quadratic trend model. Yes, uh, with yt as an output and t to the power of 2 as predictors, such as in the fashion that we do not have here. This coefficient does not really have a very like a very clear. This has not a very clear interpretation. The only interpretation that I can do from here is that there is a component that is making a quadratic trend, something looking like this or like this. Yes, so that will be a time series that is looking in this manner. So we have then the following outcome. As you can see, this is actually a quadratic function. Yes, this black line here, right? And we actually fit that using the quadratic expression in the equation before, right? These are the coefficients, the constant term, yes, is going to be around here. This is actually 1859, yes, this point here. And t, this is the coefficient for t, this is beta 1, and this is beta 2, right? And the p-values are actually very significant. Why? Because they are actually less than 5%. Right? So this is the training data scoring summary report. I recall that this is the root mean squared error. This is the average error. Yes, and the sum of the squared errors, 3 measures of accuracy, and this is the version for the validation time series. Yes, so when we calculate the forecast versus the actual validation data, we have these errors here. These errors are the ones that we are going to use. Yes, we use them to compare other forecasts, right? These results are telling us that we are going to have this error, yes, that we hope that is going to be actually fluctuating around zero, and that they are going to be at least a medium, like a mean that is constant. Okay, so in Excel, very quickly, you have the possibility of calculating a linear regression, as you can see here, right? The exponential function that we covered, and as well a polynomial. Yes, these polynomials are using quadratic functions, yes, quadratic cubic functions when they are to the power of 3, and as well equations with 4 like to the power of 4. That will lead us, and every time that you add one of them, what you are doing is to make like a break, yes, in the like regression, right? Yes, so that is what we have covered today. Remember that you can use all the time this trend line in Excel, and you will be able to find that. During the next year, right, the first seminar, we are going to go over the second part of linear regression, and we are going to calculate this using R. So bear with me, I am just explaining like the rationale of linear regression, and once we cover autocorrelation and the rest, we will be able to use the command TSLM to find a very good trend, seasonality, and other components in a dataset. All right, guys, with this I finish the the lecture for week 11, and I hope you have a very nice Christmas. So, and I hope to see you this week during my online seminars. So I'll see you then. Bye bye.